So let's just get on with today's session. I will share my screen. Can you all see my screen? Just raise your hands or give a thumb. Sorry, don't raise your hand. Just give just use the thumbs up emoji if you can see my screen. All right. Okay. So welcome to the fifth session of fifth week of problem solving through programming in C. I'm Aditya, and let's just begin the session. So let's start with a quick recap of week 5. Okay. So we saw what is the importance of syntax with conditional statements and loops. So we saw what happens if we put a semicolon at the end of the condition declaration or loop initialization. And then we saw statements like break and continue, what they do. So breaks out of either the switch case block, or any loop, and continue will just from that line it will just go back to the beginning of the loop. It will ignore whatever is there in the loop. Okay, and then we saw how some common mistakes that lead us to getting infinite loops and how we can avoid those. And then we looked at a few examples on conditional statements using if else, and then we saw loops and other small things, other nuances that are involved in this. So let's just start the session. Okay, just a minute. Yeah. So last week we discussed the ternary operator, the ternary condition. So the first task is, I have this code block where I have initialized x as an integer, and I have this long ternary block. So what will be the value of x? Okay. So I'll give you 4 minutes to look at it and solve it, and then once that is done you can just answer. I have disabled the chat for now, because some people are faster than others and they'll answer. So once these 4 minutes are done, I will just open the poll and you guys can answer. Okay. There is one more minute left. The poll is now live, so the people who have done can answer in the poll. And yeah, you may have come across this question in the last week's assignment. So since ternary operators can be a little tricky, I thought I would take it up again in this week. Okay. After this, I think there will be no repetitions. Yeah, so time is up. Yes, time is up. So let's just, I'll wait for a few minutes to get some more votes. Okay, I hope people have done this. If you have solved it, just give a thumbs up. So not many people seem to have solved it. Anyway, let's just look at the solution to it. So like I said, the best way to find out about this is just write the code and see what happens. I hope the screen is visible. It seems visible, so it's fine. 4, then not equal to 1, less than 5. So as you can see, the answer is 2, and in the polls, majority of the votes have gone to 2. So let's just break it down, right? So in this, this might seem like one long statement, but as we can see, we can break it down to 2 ternary conditions. So first one is this. I will put a bracket here, right? So whatever the output of this will be, that is the true condition for this statement. Okay. Oh, so for this statement, 3 is 3 less than 8. That's what it is asking. Is 3 less than 8? If yes, it will solve this. If no, it will just print 3. Okay, because 3 is the false condition. I mean, if the statement is false, it will print 3. If the statement is true, it will compute this. Okay, so if I change it to this thing, is 3 more than 8? It will run and it's 3. Okay, so now we go to, so now since it's true, it will print whatever comes from here. So how do we find what is this? So like we know that not has the highest precedence. Okay, this not operator, not, less than, more than, whatever, right? So we can either solve this first or we can solve this first. It will both give the same thing, and this double equal to sign has lower precedence than this comparative sign, either greater than, less than, and not. Okay, so let's just take this first. I am saying 1 is less than 5. That is true. So in C or in most of the programming languages, true means 1 and false means 0. Okay, so I'll just write here. Okay, so x equal to 3 less than 8, is that true? Right, and I'll put a space bar here. So 4 not equal to 1 less than 5. So 1 less than 5 is true, right? So I can replace that with 1, because in C true means 1 and false means 0. Okay, so I can replace that with 1. Then the next thing is not. Okay, the next in my list is not. So I will see if 4 is not equal to 1. That's also true. So I can replace that with 1. Now my last condition I have to check is 1 equal to 0? 1 is not equal to 0. That means this thing is false. Since this is false, I will take 2 here. Okay. So this whole thing's value has become now 2, and I'll add this 3 from here. So is 3 less than 8? It's true. Hence I'll print 2. So what happens if we change the way we read? So yeah, and since we are going, I made a small mistake here. Not and less than sign have the same precedence. So we'll go left to right. Right. So first I'll see, is 4 not equal to 1? That is true. So 1. So 1 less than 5 equal to 0. 1 or 2. Okay. So is 1 less than 5? Yes, true. We'll change it to 1. If is 1 equal to 0? No. So 0. So this whole thing is now just 2. 2 and 2 or 3. So this 3 came from here. So this x becomes basically 2. That's all. So is that clear? Does anybody have any doubts? You can, I'll maybe open the chat if you want to write something. If there are no doubts, we'll just move on to the next question. All right. So, wait, I made a small mistake here. Yeah, sorry. So, what is the similar kind of task? What is the output of the following code? I have declared the values of u and v as 0 and 22, and some while condition is there. So as long the conditions are true, it will keep on running. Once it becomes false, it will return the values. Okay, so I'll start the timer. Yeah, sorry for the delay. The polls are now live. You guys can just choose the answer, whatever you find appropriate. So does anyone want to have a crack at it? I mean, you can raise your hands and you can explain your approach, how you went about solving it. 21 and 2. Yeah. Kshitij Singh, you can please unmute yourself.
Sir, my answer is coming like u is equal to 6 and v is equal to 19. With
6 and
in
9.
every iteration, I increase the value of u by 2 and decrease the value of v by 1. So
Okay.
it was giving me u as 6 and v as 19. I
U
feel
as 6 and V as 19.
v might be wrong. I'm not sure about v.
Okay, so you got 6 and 19. Okay, that
Okay.
that might be true, and there's a chance that okay,
V.
19 and 6. Okay, yeah. So one thing you have to keep in mind that when
But in my
I
com-
what
but but in my compiler the result is showing like 10 and 24.
10
Value
and
of v is 10 and u is 24
24. Okay, let's just
Yes, sir. Your V is 10 and U is 24.
in the compiler.
oh
Sir, it is right. V is 24 and V is 10 and U is 24.
I don't know how.
yeah, but I've written here V minus minus. Okay, let's just
Yeah, did that only.
yeah. I mean, you must have done that. Okay, let's just see that why that happens or what we
Sir,
actually.
if there is logical AND operator, so it is not not the print. But there is comma, so it's print 10 and 24.
Yeah, yeah, but how is v increasing?
V is increasing, but V greater than 10. When V greater than 10, then that is stop. The our code is stop when V greater than 10. But when V not greater than 10, the our code is run, and V is 10 and U is 24.
No, no. See, our code will run if u is less than 7 and v is greater than 10. Okay. So uh, let's just
If
see
either
if
of
we
the
can
conditions,
change it
if
to
I,
logical and or something. Okay. Uh, let's find out together that why it might be happening. 10 and 24. Okay. So okay, wait. I think I'm not sharing my screen. Sorry. So it does seem to be 10 and 24. Okay. So let's just find out why that might be happening. So someone is saying you initialized v after u. Yeah. So if I change the comma to and that is a logical and, I'll get what I expect. I mean 18 and 8. So why does it play weirdly if I change it to what is it called? Just a comma. Okay, wait. So now it should give me yeah 10 and 24. So yeah. So like some of you pointed it out, it'll since and we also saw this in if. I mean we saw that when we write something like if x is equal to 1 comma 2 comma 0. So it will take whatever is in the, so x has been initialized as 1, but the if condition is false because whatever is in the uh, rightmost, it will just take that. Okay, so if I add 3 here, now it has become true. So similarly here in this while since there is a comma and we don't have a logical and, right? If it is just a comma, my only condition here is v greater than 10, right? So it will run for how many times? It will run 12 times till v becomes 10 from 22, and then same number of times you will get incremented by 2, right? So that is why we will get 10 and 24. So you have to keep that in mind. It was a trick question actually, and I can see that I didn't give any right options. So you should be aware that comma is not and. I mean, comma in English is and, but comma is not and in programming. Okay, so logical and is given by and like this, right? So it changes and I get this thing. So now since I have this here, I need to check both the conditions. Okay, so since I have to check both the conditions, I'll check. So this thing will get will reach first, right? Because when after 4 iterations or after the loop is run 4 times, u will become 8 and v will become 22 minus 4, that is 18. And since this is not valid anymore, it will just come out. Or if I change this to, let's say, or, now what happens? Now we'll get the same thing, right? Because whichever is, I mean, at least one has to be true. So this is now false. I mean, when u becomes 8 and v becomes 18, this is now false, but this is still true. And for or condition, any one has to be true, that's all. For and, both have to be true. Okay, so this is, I mean, so this is just a small exercise to tell you stuff about syntax. Yeah, Kshitij, do you have something to say?
Sir, but in fourth iteration, the value of u will increase by 7, will be greater than 7. So the so why didn't exit the while loop? I mean, only in the third iteration, the value of u should exit the while loop.
Yeah. See, in the third iteration, u is 6 and v is 19, right? So that is true, because 6 is less than 7 and 19 is greater than 10. So it entered the loop, v became 18, u became 8, right? 6 plus 2, 8. Then it checked again. When it checked again, I can see that 8 is not less than 7. So it didn't go inside the loop, but u is 8. That's the only reason that the loop has been exited, right? The loop was exited. So is that clear? I mean, why u is 8? Logical or comma?
Okay,
No. Comma is not logical or. Someone in the chat has asked. Comma is not logical or. Comma is just something that makes you ignore whatever is to the left of the comma. So if I write many things here, comma this, comma that, comma, I can say u less than v, right? I'll run this, so it will be this. I mean, so yeah, this is. So it will only check this, right? It will not check these two. It will only check this. So comma is not logical or. Okay. Comma is just comma. This comma, so I read this. I saw the comma. So this is useless. Then I read this. I saw the comma. So now this whole thing is useless. My only condition that it needs to check is u less than v or not. So that is what it is checking. So I think after 6 times it will 7 times 8. Okay, wait, I'm making a so after 7 times I'll get 14 and 15, right? After 7 runs, u is 14 and v is 15. So u is still less than v, and at the 8th run u has become sorry, so this is still valid, so the loop will run for the 8th time. So after 8 runs u is now uh, 16, v is 14. So now it will check again, this is not true, so it will just not do this, and it will directly print 14 and 16. Okay, so I'm just keep in mind I'm printing v first and u second. So once again, comma is not logical OR. Logical OR is this. So yeah, let's just see what happens if we run this now. 10 and 24. So yeah, so any one has to be true, right? So it is just so first this became false, then this became false, then when finally this became false, I have 10 and 24 and it came out of the loop. And now I'll change this to and. Okay, so is v. I think you will get 18 and 8, yes, because this is the first one to become false, and since this has become false, this whole thing is now false, so it will exit. Okay, so yeah, so let's move on to the next question. I hope it was clear. I hope it's clear. So let's just, I'll stop sharing this and we'll go to the presentation. Yeah, so one more task, increment and decrement again, and I think I have also, yes, I have also inserted a ternary condition here. So same thing, I have the values of x, y and z as 39, 8 and 3. I do some operation here and then I print some value, and this value that I print, it depends on this ternary condition. Okay, so this is also relatively easy, so you guys just, yeah, you will not need more than 4 minutes I guess. So I'll just start the timer and I'll, after 3 minutes I'll launch the poll and you guys can just answer. Okay. So just keep in mind the answer or the options may not always have the right answer. Okay, so you have to believe in yourself. So time's up, and I can see the votes, and I think most of you have got it right. And this is a fairly simple question, so should I skip it, or actually no, I'll not skip it. So I'll just quickly type this in. So like most of you answered, the answer is 40. So x is 39, y is 8, z is 3. So plus plus x means 40. That means z equal to, so plus plus x means 40. Y minus minus means 8, because of course it's not minus minus 5. So z is now 5, and so since z is not 5, z is 5 into 3, right, because z was 3, so star equal to is z equals z into this much, so z is now 15. So and 15 is greater than 8, hence I'll take this x plus plus, x has become 40 here, right, so it is 40. So if I change it to y plus plus, what happens? Here y is 8, but y has become 7, right. 7, right. Once I go beyond this line, y has become 8, but y plus plus, since it's post increment, it will take the value as 7. Okay, so nothing much to see here, I guess. I can just play around with plus plus, and I mean plus plus minus minus and all. So this is just for I mean it's basic understanding. So let's just quickly go to the main thing for the day, because the rest of the things are, I mean, the first 3 tasks are quite straightforward. So now you have to write a code using either for loop or while loop, or you can try with both. I'll show it with both. I mean, I just have to change one line in each, to for while to become for and for to become while. So okay, just a minute. Okay, I take the input as n. N is an integer, and I return the nth prime number. Okay, so for example, if n, my input, is 4, the output should be the prime number at the position 4 is 7. Okay, so what is prime number? You know already that it has only two factors, then 1 and the number itself, right? So 2 is the first prime number. Okay, so 2, 3, 5 and 7. So 7 is the fourth prime number, and let's say if I input as 10, I should get 29. So if we count, if so if we count, okay, so 2, 3, 5, 7, 11, see 9 is not a prime number because 9 has 3 as a factor, 11, 13, 15 is not a prime number because it has 5 and 3 as factors, and all even numbers have 2 as a factor. Okay, so I can just skip them directly. So yeah, 11, 13, 17, 19, I can't take 21 because it has 2 factors, and I mean it has 7 and 3 as its factors, 24 is even, 25 is 5 into 5, so no, 27 is 9 into 3, so no. So 10th prime number is 29. Okay, so I should get 29 as the prime number, as the output. Okay, so I'll give you 15 minutes to do it, so you can do it using both for loop, while loop, or whichever one you see fit, whichever one you prefer. Okay, before that, I hope you all know what prime numbers are. If you don't know, then just give a thumbs up. I'll explain it to you once again. Else, I'll just assume that you know and I'll start the timer. Okay, timer is on. I can see that Himanshu has raised his hand. Do you have something to say? Yeah, time's up, by the way. I understand. Uh, yeah, how many of you have solved it? You can just give a thumbs up. This question is not as easy as the other questions. Are you all there in the meeting? Hello? If you're there in the meeting, just give a thumbs up so that I know that you haven't just logged out and okay, great. Have you solved it? If you've solved it, give a thumbs up. Yes, no, maybe. Okay, anyway, I'll just then present my screen. Sorry, I'll solve it. I'll show you how it is done. Again, I hope the screen is visible. Right. So my goal is to get the nth prime number. Okay. Nth prime number. So one way you can do is you can just get the list of first 100 prime numbers, had a switch statement, and case 1 means this, case 2 means this, and write all the numbers. That is one way, but that is not logical. That is called brute force, and then it will fail if I enter a number that is more than 100. So first I said that I would take input as n, so I'll write n here. It is n, right? Let me just check again. Yeah, so it is n, and I'll write printf enter the value of n. Oh yeah, with this this is not that friendly, so I will just go back. Sorry. I'll just use this compiler because last time we saw that we have to give the input first and then something like that. Okay, so int n, enter the value of n to scanf. As usual, keep in mind the and or ampersand, its official name, I think. Yeah. So then, so let's just first try with while loop. Okay. So I'll initialize one more variable, let's say I. So how do I find that if a number is prime or not? So prime number means prime numbers have only two factors, the number itself and 1. Okay. So I have to see all the numbers that are less than it if they are its factors or not. And one thing I know that, let's say if, okay, so I'll just start the code and I'll keep a counter as, let's say I equals 2. Okay. And I'll have one more counter, let's say flag or like count equals 0. Okay. So you'll know what these two variables mean. So n is n. So, okay, so while count less than n. Okay. So count is my counter that counts how many prime numbers I have crossed. Okay, so I'll start that as 0. I'll initialize that as 0, and I know that 2 is the first prime number. Okay, so so now I have to see if the number itself is prime or not. Okay, so for int j equals 2, yeah, so I is my I are the numbers. Okay, so I is just, I'll just start with 2 and I'll just keep on increasing it. So 2, 3, 4, 5, 6 like that. So I percentage j equal to 0, then count plus plus break. So yeah, I just write part of the code, run it, and I see what is missing, and then I add it. So I will just see, I'll just run the code and see what is missing, then I'll add that. Okay, so so what did I want to print? The prime number at position n is I, right? So I have n and, sorry, I have n and I. So this is 90% wrong. Value of n is 10. I got 23. So there is one small mistake, because after 20, so wait, I'll run it again. And press 1, just 5. So there is some mistake. So let's just try to debug the code. Okay. So one thing is I have I here, j less than I. So I'm just seeing if I has any factors that are less than j. Okay, here. So if I encounter a factor, okay, so count plus plus is wrong. Okay, so count plus plus here is not correct, because I should do this. No, I can't do this. So I'll break out of this big for loop. Okay, so I have one larger method to do this. So I'll scan through the whole thing, right? I'll add one more variable, flag equals one more small mistake. This is so it's skipping. Yeah, so now it is running. So so let me just explain the code, and I'll tell you how we can, like, what we can do to improve the code. Okay, so I have declared my variables n, I, count and flag. So I have initialized I as 2 because 2 is my first prime number that I know. So that is why it is 2. Okay, and sorry, yeah, and so what I am doing in this loop, so count is counting the prime numbers I encounter. So when I hit 2 it will be 1, when I hit 3 it will be 2, when I hit 4 count will not increase, when I hit 5 count will increase to 3, like that. Okay, so and I is, I am just scanning through the numbers indefinitely. Okay, so I start with 2, then go to 3, 4, 5, 6, 7, like that. And flag is 0. So flag is, I am counting the number of factors a number has. Okay, so and I am saying, so at the beginning of each loop I have set flag as 0. Okay, and from 2, so I can't say j is 1 here, else this will be true and flag will increase. So I have to start from 2, and this means that the modulo is 0, right? So j is a factor of I. So if I encounter a factor, my flag will increase. So once this for loop is done, if my flag still remains at 0, that means I didn't encounter any factor, that means it's prime, right? So it will increase the count to count plus plus, and I is incrementing each cycle. So I have to do something with the I. You saw that when I change this to if I keep I here, so yeah, so when count reaches n, right, I increases to the next place. So if my answer is 29, I becomes 30, right? Because both the things are happening parallelly. So count has become 29 and I has become 30. So you know what I mean. So when we entered the loop, I was 29 and count reached 10. Okay, and I became 30, then when count reached 10, so that was n, so now it is 7, it exited the loop. So now I has been incremented by 1. So if I change it to I instead of minus minus I and I give 7, it will give me 18. That is the next number. That is why I need minus minus I. Okay. So it is 17, right? So 2, 3, 5, 7, 11, 13 and 17. Okay, so 17 is the 7th prime number. So what can we do to make it more efficient? Okay, so what can we do to make it more efficient? So this thing here, this flag is not actually efficient. Okay, and yeah, so can a number have a factor more than half of it? So 100's biggest factor is 50, right? So 2 is the smallest number. I mean, of course, apart from 1, 2 is the smallest number that can divide a number, right? So I can change this to I by 2. Okay, so I can change this to I by 2 because I don't have to, if I want to check if a number is prime or not, if I, let's say I want to check if 100 is prime or not. Okay, 100 it will just exit in the beginning itself. I mean, since 2 is a factor, let's say 97. Okay, so 97 is, I think, the largest 2-digit prime number. So I have 97. So if 97 is a consonant, it's still the, or 47, right? Yeah, so 97's largest multiple can be 97 by 2. So I don't have to check beyond that because it's not possible for a number to have a not multiple, sorry, factor. It's not possible for a number to have a factor more than half the number. Okay, so did you get what I said, that why I changed it to I by 2? Because there is no use checking if a number is a factor or not beyond I by 2. So if I have 10, 6, 7, 8, 9 are, they can't be factors because 5 is the greatest factor apart from 10. So if I exclude 1 and the number itself, the greatest factor will be like can be, not will be, can be only half of it. Okay, since 2 is the smallest number that can divide. So I'll run it again. I'll put 7. I get 13. Okay, so why do I get 13 here? Both I and j are int. So first it will not even enter. So yeah, I had to change it to less than or equal to because if it is odd, it will just go down by 1 position. So what happens if I run it with 10? Yeah, it gives me 23. 27 and 25 are not prime numbers. So I have to change this to less than or equal to get the right answer. Okay, so this is one thing that you can do that cuts the for time in half. Okay, so one more thing I can do here is, if this condition is true anytime, I'll just break out of the loop. Okay, so so I can just write break here, right? So okay, wait, so if I'm checking, let's say 24, so 24, what are the, I'm just checking till 12. Okay, so the factors are 2, 3, 4, 6 and 8 and 12. Okay, so it is so this condition is proving to be true a lot of times, and flag has become 2, 3, 4, 6, 8, 12, 6 times. So flag is 6 or Yeah, it is 6 and it's not 0. But my condition here that flag is 0 then count plus plus. So I can just write break here. That way, okay, I have to do this to make sure that it falls under the if. Okay, so I have to make sure that it falls under the if, because once I hit one factor, right, it will go out. So flag is still becoming non-zero. It became 1, but now I don't have to check for rest of the numbers if they are factors or not. So if I'm checking 24, the moment I hit 2, the moment I reach 2, I'm done. I'll just break out of the for loop. I don't have to do go through the loop the whole go through the loop till 12. So instead of, it's not 12, I'm starting from 2. So instead of this loop running for 11 times and flag becoming 6, I'll just run it once. So 2, I hit 2, this is true, so flag has become 1. I'll break and I'll check if flag is 1. It is not 0, so this is not executed. So see, here I don't have this, I put these curly braces to see the to just state that there are more than one statements within the within my if condition. Okay, here I don't have this, so only the statement right below it is part of this. So increment of count depends on whether if is true or not. I plus plus is going on regardless. So I change this here, right, break. So I'll run this again, I'll write 10 here, it gives me 29. Okay, does anyone have any doubts with this?
Sir, I have one more doubt.
Yeah,
That what is the sir? What is the main logic beside the prime number?
there seems to be a lot of background noise, I think. So if I heard you right, you want to know the logic behind this. Logic as in why we are doing this, or what is the logic behind
Sir,
it?
I want to say that what is the main thing that we have to mention in the program to run a prime number?
So you know what a prime number is? Yes.
So, sir, I have a confusion of what is the factors. About the term factors.
Factor means whatever perfectly divides the number. So if I have a number 9, 9, if I say 9 by 3, it is 3. So 9, and you know this, what modulo sign means?
Yes, sir. Modular side. Oh, you know.
It gives a remainder. Okay, so
Yes, sir.
if a number has no factors, whatever if I is a random number that is prime and j is some number below it, regardless of j, I'll never get 0 here. Some remainder will be there because j does not perfectly divide I, right? Yes.
Yes, sir.
So that means it is prime, right? And one more thing I did here was uh, I have limited my scan space or my search space to I by 2, because like I said, a number can't have a factor more than half of the number. Okay, so the greatest factor will be, can be, not will be, can be half of it if it is even, and if it is odd then I'm not sure. I mean, it depends on if it's, so like 21, right, its greatest factor is 7, so its factors are 3 and 7. So it is not prime because 3 and 7 exist. If I take 23, its only factors are 1 and 23. So 21 has 4 factors, 1, 3, 7 and 21. So I don't want to count 1 and 21 here. So if I see 23, it has only 23 and 1 as its factors. So I can't use those. So that means 0 proper factors, right? So that's why. So that's the logic behind if it is prime or not. So this if statement this small for, it checks whether the number is the number I. Okay, so I is I am scanning through natural numbers. I start with 2, 3, 4, 5, 6, 7, whatever. I am just scanning I, and if I is prime, I will increase my count by 1. Okay, so 2 is prime, so count I start as 0. I have declared count as 0. Flag, I will change flag to, let's say, factors. Okay, that is better, right?
Yes, sir, I understood.
Yeah, okay. So if factors are 0, that means the number is prime, so I can add one to my list. Okay, so count plus plus. Oh, so I think in week 6 you will be working with arrays. Okay, so I can using arrays, I can, instead of just saying the 10th prime number is this or 11th prime number is this, I can give a list of the first 10 prime numbers, the first 11 prime numbers, the whole list I can generate with arrays. I mean, I can still do that. I can just say count plus plus, and here I can put this in brackets. I can just write printf percentage d the prime number at position is, and I can have here n and I. Here I can have I, but here I need to put minus I because this I am writing before I plus plus. So I will comment this. Okay, I have this, and I will close this if bracket. I will run this. Okay, so yeah, factors. If I write 10 here, I got this right. Sorry, one more mistake. Not mistake, but yeah. I'll write 10 here. I'll run here. So see, I can say that prime number at position 1 is 2, at 2 is 3, 3 is 5, like this. You must have seen that those programs where you, in the lectures, it must have the star pattern, you making a triangle with stars, or like the stars like this, that. That also uses running the printf function multiple times. Okay, so yeah, Falashai has a doubt. Do you want to ask something? Okay, you have lowered your hand.
Sir,
Yeah.
sir, is there any other method other than implementing the if-else condition if stated otherwise in a question?
How else will you check if a number is prime or not? You need to check if the numbers below it are its factors or not, right? So if is necessary to do that. Yeah, I can, instead of using while here, I can use for here. Okay, so that's what I said. I'll change this to for, and I'll show that how we can. Sorry. Yeah. How we can do this with for. Yeah. So to answer your question, if is mandatory here. I mean, how else will you check if a number is how else will you check if a number is prime or not? So yeah, I can write a function, and I can just call that function here, function that checks if a number is prime or not. I'll just call that function, and but that function itself will have if, right? Okay, so now I'll just quickly show how to use for loop here. Okay, so here I'll just so I'll remove I plus plus from here, not remove, I'll just remove it like this. For I equals to, I can remove this, for I equals to I plus plus. Okay, so this is for I equal to 2, I greater than 0 and I plus plus. So after each pass 2, 3, 4, 5, it will just get incremented by 1. So this is the condition for an infinite loop, right? Because it is always greater than 0. Then how do we exit? So exit condition here will be if I have one condition here, if count equal to n, right, break, right. So if count equal to n, break. So I'll run this again, I'll say 10 as usual, and I got the answer. Okay, so I solved, now so to you can run, so some programs are more suited for loop, some programs are more suited for while loop. So this thing, it is better suited with while loop, okay, because I have to initialize this in a way that there is a chance if I make a small mistake, it will become an infinite loop. It will just keep running, and then I'll just waste my time. So when I declare something like that, right, I have to have a break statement. I have to make sure that I have to make sure that this loop, I am breaking out of this loop. Okay, so if I don't do this, then it will just keep on running. So, and there are ways to write for loop as while loops. So instead of having this here, you will have to write it inside the while loop, and the loop condition will be this, right, and this initialization will be outside the loop. It will be before the loop. Okay, so if I have a line like for I equals 0, I less than n, I plus plus is equivalent to, I can write I equals 0 while I less than n, and I open my braces statements / commands, then I'll write I plus plus here and close the loop. That's all. Okay, so this is how I can change a for loop to a while loop. Okay, so just keep that in mind. Yeah, so if it is clear, we will go to the final question for the day.
Yes, sir.
Okay, great. Yeah, the last one is also loops. I'll actually change this to, this is fairly simple. You don't need more than 5 minutes here. So write a C program where I take n as the input, and the output should be the summation of, the summation this, okay. So I need my output as sum. N is an int, but yeah, so k equals 1 to n, 2 power k by k power 3.5. So the hint that you have to use is there is a function in the math library. So like I have stdio.h, I can use math.h and I can access a function that will give me the power, okay. I have started the timer. Before that, if you have any doubts with the question, you can raise them. Yeah, Kshitij Singh.
Sir, please explain this structure again.
This what?
Summation structure. What it means? 2 की power k by k into 2 की power.
Okay, so if n is 1, you know what this summation sign means, right?
Yes, sir.
Yeah, so I do 2 power 1 by 1 power 3.5 plus 2 power 2 by 2 power 3.5 plus 3 plus 2 power 3 by 3 power 3.5 plus and so on till I reach n. That is what it means.
Okay, sir.
So you know what loop to use here, right? I mean, you have to use a for loop here. That's not even a hint. It's just I'm just straight away telling you that use for loop. Start with 1 and go till n, okay. Or you can, yeah, start with 1 and go till less than or equal to n or less than n plus 1 and I plus plus, I mean I plus plus or k plus plus or whatever variable you choose to use, x plus plus, I mean it's up to you, right? So and yeah, when I start the, so power function is there, so its name is not power, so it is for you to find out, or you'll know when I write. So or we'll do one thing, we'll just note this down and we'll solve it parallelly, okay. I hope you have noted the question down. So I'll actually stop presenting this. I'll go to my online C compiler. So like I mentioned, you have to use math.h, okay. So double sum, I'll also use k here. So you know what double means, right? You have int, you have long int, you have float and you have double. So int is just for integers and long is one more variable name for a very long integer. That means a very big integer. And I have float and then I have double. So double gives me more accuracy with the decimal points. I mean, I'm not looking for 10 15 points here, so I might as well write this as just float. So I'll just write float here because I don't need that much accuracy. And yeah, this k also, although I know that k is basically it's going from 1 to n, so 1 2 3 4 5 6 whatever integer, but since I'm performing mathematical operations on it and I need accurate answer results, I have to declare it as float, or I can just declare it as int, and while computing I can just write float and brackets this k. It's up to me. I chose to declare it as float, so I'll take the input enter n. right. So now, like I said, for actually, since I'll be using k here, I can either play the long game, or I can just initialize I here. Yeah, so time is up. I mean, it doesn't matter. For I equals 1, I equals 0, I less than n. So sum, right. So if I'm starting with 1, so I start with sum as 0, right, and I keep on adding the numbers, right. So I can just write sum plus equal to like this. I don't like to do that, so I'll just write sum equal to sum plus and this thing. So what is this? This is 2 power k by 3.5. So in math.h there is one function called pow, that is power. So see, when I write sum, the font color, the text color remains black. When I write plus or this thing or scanf, printf, it becomes gray. I mean, I don't see, I believe you can see that slight difference between black and gray. So when I write pow, it becomes gray because pow is a function, not a function as in pow is an inbuilt function. So the syntax for using pow is, if I want 2 power n, I'll write 2 here, I'll just write 2.0 for, I don't know, comma the power. Okay, so base and the power, base comma power, right, exponent. That is the syntax. So 2.0 comma, what is it, k, right, yeah, divided by again pow k power 3.5, right, just like k plus plus. I can do the same thing with I, I'll just check if it is possible or not. Check with 2. Okay, so I forgot to print the result. Printf, the sum is percentage so if I say 2, I'll get this answer. So if one of you can verify, so yeah, 1 should give me 1, right, 1 should give me 2, yeah, sorry, because 2 power that thing by 1, 2 power 1 by 1 power 3.5, so 1 should give me 2 and 2 should give me 1. Okay, I'll just check one small thing if to see if I'm right or wrong. Change this to k, change this to 1, k less than or equal to 1 and k. Just see if it runs. Yeah, it runs. So I don't need to declare one extra variable here. Okay, and I don't need to initialize this as well because it is float, right? So I don't have to specifically say that it is 1.0. 1 is enough because it is float already, right? So I'll just run it again. I'll say, I'll check for 3. It's giving me some answer which is I'm hoping it is correct, or I'll open my calculator app here and so 2 power I'll check for 2. Okay, so 2 is giving me 2.3536. So 1 was 2. So 2, if I substitute k with 2, it should be 0.3536. So I'll open my calculator. I do 2 power 2 is 4. So 4 divided by 2 power 3.5, right? So 2 power 3.5 divided by 4. Yeah, so 0.35355539, etc., etc. So my answer is correct. Did people try doing this on their own? I mean, I hope you did. I didn't give you time to do it because there was not much time left. So do you have any doubts with this? Is the code clear? Code is not clear. Okay. So math.h for mathematical functions, power, syntax I told you, base and the exponent, base and exponent, division means division, and 1 less than or equal to n. So I reach n, right? If I do this, I don't reach n, I stop at n minus 1. Okay, so to make sure that I reach n, I'll do this, or I can do this, n plus 1. Okay, whatever. So, and k plus plus. So each time I take n as my input to see how many terms I want in my summation, and I declare, since I am performing pow and division operations here, I have to declare k as a float and not an int. N is an int, sum is also a float, right? So I take the value of n and I start the loop. So k is 1 at the beginning, k is less than or equal to n, k plus plus. This is the condition that it has to check if it is true or not each time, and increment is here. Okay, so sum was 0. So when k is 1, 0 sum equals 0 plus this thing with k as 1, right? So 2 power 1 by 1 power 3.5 is 2. So sum is now 2. I'll go increase k by 1. So k is now 2. So sum is now 2 plus whatever I get here when I substitute the value of k as 2. Okay, so I get 0.35355 something, some long number. I cut it short by 4. So this 0.4f here, it means that I need 4 places after the decimal point. So I'll change it to 6 and we'll see what happens. So now I have 6, right? 353553. Okay, so this is fairly simple. I mean, you should be the judge. Is this clear? Somewhat? Yes, no, maybe? All right. So practice more of this. This week's lectures are on arrays. Okay, so it's a very fun topic. Data structures have risen from arrays. Okay, so it is very useful if you want to pursue your career in that. This, yeah, plus of course you need some logic. So knowing how loops work, knowing how if condition, else condition works, that is very important. So that will be all. Let's just break for the day then. Have a good day. Bye.
Thank you, sir.
Okay. Yeah, you may now leave the
Thank
meeting.
you, sir.